Hello students, in this video we will be seeing the solutions for previous year question papers for NEET Physics. So particularly we will be focusing on the topic work, energy and power. So before going inside the questions, we will just see the statistical analysis about the previous year questions, like in which part of the unit more number of questions were coming. So if you split the unit, we will be having 5 different parts. The first one is work, next one is energy, and the third one is work energy theorem, power and collisions. So if you see, for the past 33 years, about 20% of questions were coming from work, and about 39% were coming from energy, and 6% from work energy theorem, and 14% from power, and 21% from collisions. So this was the scenario for the past 33 years. But as you see, for the past 8 years, the scenario was 22% were coming from work, and 11% was coming from energy, and 17% were coming from work energy theorem, and 17% from power, and 33% from collisions. So if you see the past 8 years, the scenario is about 33% of questions were coming from the topic collisions. So as a whole, if you look, more importance were given to these two particular topics like work and collisions. So in this video, we will be addressing all the 5 different topics, like we will be trying to solve the previous year questions which contains all these 5 different topics. So let us move on with the first question. A force F is equal to 20 plus 10y acts on a particle in y direction where F is in Newton and y in meter. Work done by this force to move the particle from y equal to 0 to y equal to 1 is. So what they are saying is, they are saying that a force is acting on a particle in y direction where F is in Newton and y is in meter, and work done by this force to move the particle from y0 to y1. They want us to calculate what is the work done to move it from y0 to y1 or y equal to 1. Okay, so here if you take the y initial is 0, it is at the 0 position, and y final is 1. So that's what they are saying. So work done by the variable force is given by W is equal to y initial and y final, and here you will be having F dy. Okay, so this will become 0 to 1 because y initial is 0 and y final is 1, and the force they have given us 20 plus 10y. So you are going to substitute here 20 plus 10y into dy. Okay, so if you integrate this, you know, you will be getting it as you can take this constant terms and all outside. Okay, so you can take it as 20 integration of 0 to 1 dy plus 10 integration of 0 to 1 y dy. Okay, so here you can just if you integrate this, you will be getting it as 20 y 0 and 1 plus, here again if you see, you will be getting it as y integration of y is y square by 2. So this will become y square by 2, where you are going to apply the limits. So this will become again 20, and this will also become 1. So it will be 10 by 2, so it will become 5. So the answer will be 25 joules. Okay, so the correct option is option number 1, 25 joules. So you require the work done by the force to move the particle from y equal to 0 to y equal to 1 is 25 joules. So you require the amount of work to be done is around 25 joules to move the particle from y equal to 0 to y equal to 1. The next question is, a particle moves from a point minus 2i plus 5j to 4j plus 3k. When a force of 4i plus 3j Newton is applied, how much work has to be done by the force? So here again they want us to calculate the force. So first we will calculate the distance, that is the particle is moving from one position to another position. So first you have to find out how much distance it has moved. Okay, so for that you will be writing it as S is equal to R2 minus R1. Okay, so R2 is the position of the particle after a force is being applied. Okay, so R2 is 4j plus 3k here. So it will become 4j plus 3k minus, and R1 is minus 2i plus 5j. Okay, so this will become eventually it will be 2i, and this is 4j and minus 5j, so it will become minus j, okay, plus 3k. Now you know they have told that the force applied F is equal to 4i plus 3j. So you know that the work done is equal to force into the displacement. Okay, so F into S, so it will become 4i plus 3j into 2i minus j plus 3k. Okay, so if you solve this, you know 4i into 2i is 8, and 3j minus j is minus 3, and there is no k component, so that will become 0. So it will become W is equal to 5 joule. Okay, so the work done for moving a particle from a particular point 2i plus j 5j to 4j plus 3k is 5 joules. So the correct answer is option number 4, 5 joules. Okay, we will move on with the next question. A uniform force of 3i plus j Newton acts on a particle of mass 2 kg. Hence, the particle is displaced from a position 2i plus k meter to position 4i plus 3j minus k meter. So again they want us to calculate the work done by the force on the particle. So this is also similar to the previous question. So first you write down what is the force acting on the particle. F is equal to, here they are given it as 3i plus j. So this is the force which is acting on the particle of mass 2 kg, and they are saying two different positions. So R1, first you write down what is R1 is. R1 here it is from position 2i. So R1 is 2i plus k, and R2 will be 4i plus 3j minus k. So first you calculate the displacement. S is equal to R2 minus R1. Okay, so this will become again 4i plus 3j minus k minus 2i minus k. So this will become 2i plus 3j minus 2k. Now you have to calculate the work done. So W equal to F into S. So you know what is F is? F is 3i plus j into 2i plus 3j minus 2k. Okay, so if you solve this, you will be getting it as 3i into 2i is 6 plus again 3, and here there is no k component, so this will become 0. So you will be getting the work as 9 joule. So this much amount of work has to be done to move the particle or to displace the particle from one position to another position. So the correct answer is option number 1, 9 joules. Okay, so we will move on with the next question. A body of mass 3 kg is under constant force which causes a displacement s in meters in it. Given by the relation S is equal to 1 by 3 t square, where t is in seconds, work done by force in 2 seconds is. So they want us to calculate the work done by a force within 2 seconds. So here they are given a condition is the body is of mass 3 kg is under a constant force. So they are going to apply a constant force on a body. So because of the force, what happens is the displacement takes place. So the displacement S is taken place in meters, which is given by the relation S equal to t square by 3. So here what they have given is S is equal to t square by 3. So they want us to calculate it for 2 seconds. So for 2 seconds, what will happen? T will become 4. Okay, sorry, T will become 2 and T square will become 4. So S will become 4 by 3 meters. Now they want us to find out the force, like work done. So you have to note down what is the change in displacement with respect to time. So ds by dt is equal to, you will be getting 2t by 3. That is, you are differentiating this. S is equal to t square by 3. You are going to differentiate that. You will be getting it as 2t by 3. And you know A is d square s by dt square. So again, if you differentiate, you will be getting it as 2 by 3 meter per second. So you have got the acceleration value. Now you can easily calculate the force. So force is equal to ma, and here what they have given us, the mass is 3 kg. So 3 into 2 by 3. So this will become 2 Newton. So the force acting on the body is 2 Newton. So the constant force which is acting on the body. Now you have to calculate the work done. So you know it's a very simple formula. W is equal to F into S. So you will be getting it as F into S means, here you know what is the value of F, it is 2 into, and your S value is 4 by 3. Okay, so you will be getting it as 8 by 3 joule. So the work done is 8 by 3 joule. So this much amount of work has to be done in order to move a body from a particular position. So the answer is option number 4, 8 by 3 joule. The next question is, force F on a particle moving in a straight line varies with distance d as shown in the figure. The work done on a particle during the displacement of 12 meter is. Okay, so they are given a graph which is a variation of force with the displacement. So in x axis the displacement they are given, and in y axis they are given the force. So if you want, they want us to calculate the work done. So work done can be calculated by measuring the area of this particular rectangle. Okay, so you can mark it as A, B, C and D, and this you can mark it as E. Okay, so area of this rectangle ABCD plus area of the triangle DCE. Okay, so here if you see, area of the rectangle is, the height is 2 and this one is 4. Okay, this difference 7 minus 3. So 2 into 7 minus 3 plus here half into again 2 into 12 minus 7. Okay, so this will become 2 into 4 plus this 2 gets and it will become 5. So it will be 8 plus 5, which is equal to 13 joules. So the work done is 13 joules. So the correct answer is option number 4. A body of mass 1 kg is thrown upwards with a velocity 20 meter per second. Its momentarily comes to rest after attaining a height of 18 meters. So how much energy is lost due to the air friction? So here they are given the G value as 10 meter per second square. Okay, so initial kinetic energy is half mv square. Okay, so here they have given the mass as 1 and the velocity as 20. So this will become half into 1 into 20 the whole square. So if you solve this, how much you will be getting is 20 the whole square will become 400 and divided by 2 it will become 200. Okay, so 200 joules will be getting. Now potential energy at the maximum height is given by mgh. So here they are given the mass as 1 into g, they have told us to take it as 10 into the height. So they are given it as 18. So if you solve this, you will be getting the potential energy as 180 joules. So how much energy it has lost is, if you subtract the initial kinetic energy with the potential energy, you will be getting the energy how much it has lost due to the air friction. Okay, so if you solve this, you will be getting this energy lost is 200 joules minus 180 joules. So this will become 20 joules. So this much of energy is being lost by the particle. So the answer is 20 joules. Option number 4 is the correct answer. Okay, we will move on with the next question. A body of mass 4m is lying in xy plane at rest. It suddenly explodes into 3 pieces. 2 pieces of each mass m move perpendicular to each other with equal speeds v. The total kinetic energy generated during the explosion is. So in order to solve this problem, you can use the law of conservation of momentum by taking the magnitude of momentum of heavier piece and equating it with the magnitude or with the magnitude of sum of the momentum of pieces of mass m. So according to this question, if you see, the two pieces each have mass m and the total mass is 2m. The third piece have remaining mass of 2m. Okay, so the third part moves back since the total momentum after explosion should be remaining 0. Okay, so the initial momentum pi is 0 and the final momentum pf is also equivalent to 0. So it will become mvi plus mvj plus p3. Okay, so here this p3 is given as mv root 2 and m3 is given as 4m minus 2m. So this is 2m. So the kinetic energy of the third piece is given by p square 3 by 2 m3. Okay, so p square 3 means it is half mv square, so you are taking it as p square 3 by 2 m3, which is equivalent to again p square p3 the whole square by 2 into 2m. Okay, so the total kinetic energy is given by p3 square by 2 into 2m plus half mv square plus half mv square. So if you try to solve this, you will be getting it as 2m square v square by 4m plus mv square. So again, if you solve this, you will be getting it as 3 mv square by 2. So the total kinetic energy generated during the explosion is 3 by 2 mv square. So the correct answer is option number 2. Okay, so we will move on with the next question. A solid cylinder of mass 3 kg is rolling on a horizontal surface with velocity 4 meter per second. It collides with a horizontal spring of force constant 200 Newton per meter. The maximum compression produced in the spring will be. So according to the law of conservation of energy, here half mv square plus half I omega square is equal to half kx square. So where k is the spring constant. Okay, so I, you know, I is equal to mr square by 2. So here u is equal to r omega. So omega will become u by r. So you can substitute in this formula. You will be getting it as m half mu square plus half into mr square by 2. So instead of I, you are substituting this into u square by r square. Okay, because instead of omega, you are going to substitute it as u by r is equal to half k x square. Okay, now you know this 2 will get cancelled. So you will be having it as half mu square plus 1 by 4 m u square equal to half kx square. Okay, so if you solve this, you will be getting it as 3 by 4. Okay, 4 and this will become 2. So it will be 6 by 4. So 3 by 4 you will be getting here. 3 by 4 mu square equal to half k x square, or x square will become 3 by 2 m u square by k. So here already they have given you the mass as 3 kg. So m is 3 and velocity is 4 and the spring constant is 200. So you have to substitute here. So mass is 3 kg and u is 4 meter per second and k is 200 Newton per meter. So if you substitute this, you will be getting it as x square equal to 3 by 2 into 3 4 the whole square by 200. So if you solve this, you will be getting the value of x as 0.6 meter. Okay, so the maximum compression produced in the spring will be around 0.6 meter. So the correct answer is option number 2. Okay, so we will move on with the next question. A block of mass m is attached to the lower end of a vertical spring. The spring is hung from a ceiling and has force constant value k. The mass is released from rest with the spring initially upstretched. The maximum extension produced in the length of the spring will be. So, by laws of conservation of energy, decrement in the gravitational potential energy is equal to the increment in spring potential energy. So, it will become mg x is equal to half k x square. So, this and this will get cancelled and you will be getting the x value as 2 mg by k. Okay. So, the maximum extension produced is 2 mg by k. So, option number 1 is the correct answer. Okay. So, we will move on with the next question. A nucleus of uranium decays at rest into nuclei of thorium and helium. Then, so what they are saying is, according to the conservation of linear momentum, Pf is equal to Pa. So, here uranium decays at rest. So, Pf is equal to Pa equal to 0. So, P helium minus P thorium is also equivalent to 0, or P helium equal to P thorium. So, what happens here is, you know that K is equal to P square by 2m. So, here K helium, that is the momentum of helium, will be higher than that of the thorium. That is the kinetic energy of the helium will be greater than that of the thorium, because mass of the helium is lesser than mass of the thorium. So, here you can see the kinetic energy is inversely proportional to the mass. So, what happens here is, the helium nucleus will be having a more kinetic energy than the thorium nucleus. So, option number 2 is the correct answer. The next question is, an object of mass 500 grams initially at rest is acted upon by a variable force whose x component varies with x in the manner shown. The velocities of the object at the points x equal to 8 meters and x equal to 12 meter would have been respective values of nearly. So, what they are saying is, they want us to calculate the velocity at two different points at x equal to 8 meters and x equal to 12 meters. So, we know from work energy theorem, del Ke is equal to work is equal to area under the graph. Okay. So, fx graph. So, you have to calculate the area under the graph. So, from x equal to 0 to x equal to 8, we will be having it as half me square equal to 5 into 20 plus 3 into 10. Okay. So, this is the area under the graph, and if you solve this, you will be getting the v square value as 520, or v is equal to root of 520, which is equivalent to 22.8 or 23 meter per second. So, we have calculated the first velocity value, which is equivalent to 23 meter per second. So, similarly, we can calculate it from x equal to 0 to x equal to 12 in a similar pattern. Okay. So, again, if you calculate that, what you will be having it is, you will be getting it as half mv square is equal to 100 plus 30 minus 47.5 plus 20. So, if you solve this, you will be getting it as half mv square equal to 102.5, or v is equal to 2 into 102.5 by 0.5. Okay, it's v square, and here they are giving it as 500 grams, we are converting it to kg, so it will become 0.5. So, if you solve this, you will be getting the value of v as root of 410, or v is equal to approximately equivalent to 20.6 meter per second. So, the correct answer is option number 4. So, the velocity at x equal to 8 meters is 23 meter per second, and x equal to 12 is 20.6 meter per second. Okay, so we'll move on with the next question. A block of mass 10 kg moving in x direction with a constant speed of 10 meter per second is subjected to a retarding force F is equal to 0.1 x joule per meter. So during its travel from x equal to 20 meter to 30 meters, what will be its final kinetic energy? So they want us to find out the final kinetic energy. So you know, work equal to kinetic energy, that is the final kinetic energy minus the initial kinetic energy. So here you want to find out the final kinetic energy. So you can take this to this side, equal to W plus this is kinetic energy initial. Okay, so you know, kinetic energy final is equal to W plus half mu square. Okay, so this will become minus 0.1 20 to 30 because that is the distance. Okay, x dx plus half into m u square. So here they are given the velocity as 10, so 10 the whole square. So this is for w. Okay, where a point is the point one is the force, and 20 to 30 into x dx, x into dx is the displacement. Okay, so if you solve this, you will be getting it as minus 25 joule plus 500 joule. So if you solve this, you will be getting it as 475 joule. So the correct answer is option number 1. So the final kinetic energy is 475 joules. Okay, so we will move on with the next question. The heart of a man pumps 5 liters of blood through the arteries per minute at a pressure of 150 millimeter of mercury. If the density of mercury will be 13.6 into 10 power 3 kilogram per meter cube and G equal to 10 meter per second square, then the power of the heart in watt is. So here they want us to calculate the power of the heart. So power of the heart is given by F into velocity. So the force is force by area into area. So you are multiplying area on numerator and denominator into velocity. Okay, so you know, F by A is the pressure into area into displacement by time. So velocity is the change in displacement by unit time, so it will be getting this. Okay, so you know this, so this will become pressure into volume by time. So this will be P dV by dt is equal to H rho G into dV by dt. So here rho is the density, G is the acceleration due to gravity, and H is the height here. Okay, and dV is the dV by dt is the change in velocity. Okay, so here if you see, you are going to substitute all this value over here, and you will be finding out the total power. So here H is rho is 13.6, so that you can write down, and how much height it is moving is 5 liters of blood. So H is 5, and next one is G value. So G value will become, okay, here they are given the value of H as 0.15. Okay, so because it is 150 millimeter, you are converting it into meters. So H value is 0.15, and next is rho. Rho they have given it as 13.6 into 10 power 3, and G value they have told us to take it as 10, and dV by dt will become 5 into 10 power minus 3 by 60. okay, because the time is per minute. They have told that it pumps 5 liters of blood through the arteries. So dV by dt will become 5 divided by 60. Okay, so you're going to substitute it here. So this will become 0.5 into 13.6 into 10 power 3 into 10 into 5 into 10 power minus 3 divided by 60. So if you solve this, you will be getting the values 1.70 watt. Okay, so the power of the heart is 1.70 watt. So the correct answer is option number 2. Okay, so let us move on to the next question. A car of mass m starts from rest and accelerates so that the instantaneous power delivered to the car has a constant magnitude p0. So the instantaneous velocity of the car is proportional to, so they want us to calculate the instantaneous velocity, and it is proportional to what value they are asking us to find out. Okay, so here they have given the magnitude p0 is equal to fv. So p0 will become mav. Force equal to mass into acceleration. So acceleration, you know, it is change in velocity per unit time. So this will become p naught equal to mv into dv by dt, because acceleration is dv by dt, and p naught dt is equal to mv dv. Now you are going to integrate both the sides, so that we will be getting the value. So it will be 0 to t p naught dt is equal to 0 to v dv. Okay, so you will be getting it as p naught t equal to, here you will be having it as m, you will be having a m here. Okay, so m v square by 2. So you can take this v square here, and this will become 2 po t by m, or v will become 2 po t by m whole power half. So you can see the velocity, instantaneous velocity, is proportional to the square root of time t. Okay, so the correct answer is option number 2. So the instantaneous velocity is directly proportional to the square root of t. So option number 2 is the correct answer. Okay, let us move on to the next question. A body projected vertically from Earth reaches a height equal to Earth's radius before returning to the Earth. So the power exerted by the gravitational force is greatest. So they want us to find out at what point the power is maximum. So you know that power is given by force into velocity. When an object is thrown upwards, gravitational force acts on its opposing direction. Okay, so when an object is falling downwards, the gravitational force acting on it will be positive, but when it is throwing upward, the gravitational force will be negative. So hence the force exerted by the gravitational force is maximum when velocity is maximum during the fall of an object. So for a falling object, its velocity is maximum just before it hits the ground. Okay, so like force exerted by gravitational force will be maximum when the velocity is maximum during the fall of the object. So when an object is falling, what happens is the velocity is maximum just before when it is going to hit the ground. So hence the power exerted by the gravitational force is greatest at the instant just before the body hits the earth. Okay, so you can see option number 2 is correct. At the instance just before the body hits the earth, so the power exerted will be very large, because the maximum velocity will be exhibiting by the body. That is, when the body is falling down, the velocity will be maximum just before when it is hitting the ground. So again the power will also be maximum. That is, the power exerted by the gravitational force will be maximum when the body is about to hit the ground. So the correct answer is option number 2. Okay, let us move on to the next question. An engine pumps water through a hose pipe. Water passes through the pipe and leaves it with a velocity of 2 meter per second. The mass per unit length of water in the pipe is 100 kg per meter. What is the power of the engine? So they want us to calculate the power of the engine here. So again in a similar manner, P is equal to Fv. Okay, so P is equal to ma v or m into v by t into v. So this will become mv square by t. So you know p is equal to v square pa l by t. So you can substitute here, p is equal to v square p a l by t. Okay, so p a v cube is equal to mu v cube. V cube. So p is equal to 100 into 2 the whole cube. Okay, so here they are given you the mass per unit length is 100, so I am putting it as 100, and 2 is the velocity, so 2 cube of that, so you will be getting it as 800 watts. So the power of the engine is 800 watts. So the correct answer is option number 4. Okay, so we will move on with the next question. Body of mass 4m moving with a speed u collides with another body b of mass 2m at rest. So the collision is head on and elastic in nature. After the collision, the fraction of energy lost by the colliding body a is. So here what they are saying is the fractional loss. They want us to calculate the fractional loss of the kinetic energy of the colliding bodies. So which is given by del k by k is equal to 1 minus m1 minus m2 by m1 plus m2 the whole square. Okay, so here they have given you the mass as 2m and 4m. So m1 they have given it as 4m and m2 as 2m. So 1 minus 4m minus 2m by 4m plus 2m the whole square. So if you see the m and will cancel, and this will be 4 minus 2 is 2 and 4 plus 2 is 6. So this will become 1 minus 2 by 6 the whole square. So if you solve this, you will be getting it as 8 by 9. So after the collision, the fraction of energy lost by the colliding body is 8 by 9. So the correct answer is option number 4. The next question is, a moving block having mass m collides with another stationary block having mass 4m. The lighter block comes to rest after collision. When the initial velocity of the lighter block is v, then the value of coefficient of restitution E will be. So they want us to calculate the value of restitution E. So here what they are given is, first the mass of the first block is m and the second block is 4m, and here they are given the velocity u1 is equal to v and u2 is 0 and v1 equal to 0. We have to find out what is v2 is. Okay, so according to the law of conservation of momentum, we know that m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. Okay, so here u1 is v and m1 is m, so mv you will be getting, and here u2 is 0, so this component will become 0, and here m1 v1, again here v1 is 0, so this will become 0, and m2 they have given it as 4m into v2. Okay, so if you solve this, you will be getting v2 as v by 4, because m and m will get cancelled and this 4 will be going to that side, it will become the denominator. Now the coefficient of restitution is given by E is equal to v2 minus v1 divided by u1 minus u2. Okay, so here v2 is v by 4 minus v1 is 0 divided by, and again u1 is v and u2 is 0. Okay, so if you solve this, you will be getting the value as 1 by 4. So your E value will become 0.25. Okay, so the correct option is option number 2. The value of coefficient of restitution is 0.25. Okay, we will move on to the next question. Two identical balls A and B having velocities of 0.5 meter per second and minus 0.3 meter per second respectively collides elastically in one dimension. So, the velocities of B and A after the collision respectively. Okay, since they are colliding elastically, what happens is when two bodies with the same mass, when they are colliding elastically, their velocities gets interchanged. So, here if you see, the velocity of the first ball is 0.5 and the second ball is minus 0.3 meter per second. So, this is 0.5 meter per second. Now, when A and B is colliding, what happens is since they are having the same mass and since they are colliding elastically, what happens is their velocities gets interchanged. So, now the new velocity will become minus 0.3 meter per second and for B it will become 0.5 meter per second. So, the correct answer is option number 4, minus 0.3 meter per second and 0.5 meter per second. Let us move on to the next question. A ball is thrown vertically downwards from a height of 20 meter with an initial velocity v0. It collides with ground, loses 50% of its energy in collision and rebounds to the same height. So, the initial velocity v0 is taken, you are going to take g as 10 meter per second. Okay. So, velocity v after rebound can be given as v is equal to root of 2gh. So, which is equal to 2 into 10 into 20 because h is 20. So, this will become 20 meter per second. So, the kinetic energy just after collision is given by k is equal to half mv square. So, it will become half into m into 20 the whole square, okay, because they given the velocity as 20. So, it will become half mv square. Now, if you solve this, you will be getting it as 200 m. Okay. So, as the ball loses 50% of energy in collision, its initial energy would be 400 m. So, by conservation of energy, we can say it as half mv naught square plus mgh equal to 400 m. So, half mv naught square plus m into 10 into 20 equal to 400. So, half mv naught square plus 10 into 20 equal to 400 m, or v naught square equal to v naught square plus 400 equal to 800. So, if you solve this, you will be getting the v naught value as 20 meter per second, okay, because this is 20 into 10, you will be getting it as 200 and already on 400 is there, okay, and here instead of m you will be substituting. So, you will be getting it as v naught square plus 400 equal to 800. So, the v naught value will be 20 meter per second. So, the correct answer is option number 3. I think this video would have been useful for you to revise the chapter work, energy and power, and you would have got some idea about solving some of the critical problems which were asked in the previous year NEET examination. So, I wish you all good luck for your exam, prepare well and all the best. Thank you.